Welcome back. In this video, we are going to make sure that projectiles hit us regardless of how fast we are going, and that's going to require some changes to the way that we deal with the physics of collisions. So I'll see you in there. Great to be back with you. Just before I dive in, I'm going to do something. I'm going to go into Edit, Project Settings, and Editor. That's the menu breakdown there, and then I'm going to change under the Editor settings, under version control, I'm going to change the asset serialization to forced text. So that's asset serialization to forced text. Now I'm doing this because I'm using a version control system. I'm using Gitkraken, which is based on Git. And when I change things like prefabs and scenes, because they're binary files, you can't see what's changed. And I want to start being able to have a little look into these things that are changing and find out what's changed in text. So it's going to take a little bit more space on the disk potentially, but it's worth doing because it helps us to see what's changing. So when I do that, a whole bunch of things are going to go and change in my project. There's going to be all sorts of .asset files that used to be binary and are now becoming a text format of some sort, often YAML, yet another markup language. So there's just a quick change I'm going to make, and we'll see the benefits of that later as we start to track or visualize changes in prefabs and scene files. All right, so that's that. Now, I'm going to start talking about projectiles. So we have an enemy here, this guy, I've called him Bertie, and I've expanded his radius, his attack radius out a little bit, and just popped the player here, just you know, at a reasonable distance from him. So let's have a look at what happens when Bertie fires projectiles at the player. Well, if the projectile is sufficiently fast, like this fast projectile he's using, at 500 in this case, it just passes straight through the player. And we talked about why in a previous video. The projectile starts above Bertie's head, and by the next frame, that projectile has passed all the way through the player. So there's not a single frame when the projectile is actually overlapping with the player. Now, one strategy for this may be to do some raycasting. I'm not going to use that strategy, but I am going to introduce you to the concept. We could use raycasting or line tracing. So the projectile starts here in this frame. We call this the previous frame position. In this frame, the projectile is here on the right-hand side in position 2. What we could do is line trace between those 2 points, and then when we hit the player's capsule here, we would find that that line trace has a hit going along this line. So you just say line trace from current position to previous position. You hit the player, and then you could cause the damage and make the reaction. All very well, and that's a reasonable strategy. My concern is this really feels like something the engine ought to be doing for us. Somehow, we ought to have the engine be able to detect collisions in this instance. And you need to use something called continuous collision detection or continuous dynamics. So let's look at collisions in a bit more detail. Firstly, for perspective, if you look for Unity collision action matrix on Google. I'm going to start, by the way, giving you more search terms to look for rather than actual URLs in your resources, because those actual URLs can go out of date, but the search terms should always be there. And you want to, in reality, when you're developing games, you're not going to be relying on me giving you actual direct URLs. So why not think about how we search for things? So the Unity collision matrix is one good search term. Brings up this thing. When you see this thing here, by the way, remember that there is basically, these two tables could easily be overlaid on top of each other, because this section here, which is talking all about collisions rather than triggers, could be overlaid into here, and then you end up with a single table. So I'm not sure why Unity give us two tables. It would be easier to conceptualize as a single table. So that is when collisions happen, and whether they report an on-collision enter or an on-trigger enter. That's the big picture, but we need to look in a little bit more detail now. We need to look at what's happening with regards to discrete and continuous collisions in Unity. Now, if we type continuous collision detection Unity, something like that, then scroll down and you find the manual on the rigid body, not the Unity manual about colliders, which is what I just showed you, but about when you look at the rigid body, you'll find it's got a load of properties. And one of the properties you may have seen is this stuff here about collision detection, discrete, continuous, continuous dynamic. In the engine, it's actually here. So we look at the projectile and you look at its rigid body component, you have continuous collision detection, discrete, continuous, and continuous dynamic. We need to drill in a little bit to what that, sorry, I didn't mean to click off it, to what that means, those three options there, okay? So that's what this rigid body article is talking about. And there's a big old paragraph here and a bunch of other blurb there and there. And what I want to do is break that down a little bit, because use discrete collision detection against dynamic colliders with a rigid body and blah, blah, blah. You see, you're falling asleep, right? And so am I. So you need to read this quite slowly. And an approach to doing that is to build yourself a table. And I'm also going to change the terminology a little bit. These are the settings on the two bodies. So discrete, continuous, or continuous dynamic. That's the drop down that I showed you on, say, the projectile here. And then you've got the same settings, of course, on the player to consider on his rigid body. So, or her rigid body. So it's the interaction between that setting on, say, the player on the left and the projectile along the top, all right, or any two objects. Then I'm going to create a new term, which is whether or not it does slow or fast collision detection. Now, the blurb that you're reading on this web page uses the word continuous and discrete. I'm just saying simply that slow equals discrete and fast equals continuous. Otherwise, we've just got too many continuous and discretes flying around, and it's not clear whether we're talking about the setting being discrete or the actual detection being discrete. So I'm going to use slow, where it means the projectile basically would pass through, and fast, which means that it probably wouldn't pass through. Let's look at how this works. If either of them are set to discrete, then we get the slow type of collision detection. By slow, we mean that it will miss collisions. It doesn't mean it's slow to compute. It's actually faster to compute, okay? But it's slow in terms of its response to collisions. Then, if we have continuous set, well, as the manual says, it depends what we're colliding with. It will do slow detection or discrete detection against dynamic colliders, things that have a rigid body, and fast or continuous detection against things that don't have a rigid body. Basically, look, we don't need to analyze this in too much depth. The point is that when you are faced with a lump of text like that, I would grab yourself something, a bit of paper, even a Google slide, and lay it out neatly, and make yourself some notes. Make yourself your own internal blog, some notes, share it with somebody, whatever. Think about how these interactions work. So we've got ourselves a projectile that is going to need to have fast detection when it collides. And then we've got to say, well, here are the fast options, 1, 2, 3. What do we want to set the player as? Well, it looks like the player, it depends whether the player has a rigid body or doesn't have a rigid body. Now, the player does have a rigid body, so we need to be continuous dynamic on the projectile and continuous on the player to put us in continuous dynamic against continuous here, to put us in this cell. Okay, so continuous dynamic on the projectile. Let's go ahead and do that on all our projectiles. Now, I did say that we will centralize our projectile setup. We will do that by things like spawning required components at runtime and whatever else we need to do, scriptable objects, whatever, but we'll do that in the next section. For now, let's set continuous dynamic collision detection on the 3 projectiles. Let's see what effect that's had for a start. Hasn't fixed the problem. Now let's go to the player, and there's a couple of things we need to do. You also need to note that this whole game only works for rigid bodies. It doesn't work for trigger colliders. So I'm going to need to turn is trigger off on the projectiles as well. So they're actually becoming physical colliders. Let's see the effect of that one. Oh, now that collider has just knocked the player for 6 right onto the bridge. So what do we do about that? Well, you could turn the mass of the rigid body down for a start to 0 or very low. Now the balls are just jumping all over the place. They're having a side effect, making the enemy duck sometimes, which we can deal with later, but they are hitting him even at this speed of 500. So this is progress. This is really cool. Now, are they reliably hitting him? They do seem to be, but we still decided that the player ought to have continuous collision detection. So let's deal with that as well. Let's set the player's collision detection to continuous. Now we should get pretty reliable hits. Now the physics will be off, as the manual explains in these cases, because this is an inter-frame collision. You can see this weirdness going on. It seems to have a double movement. But we're not interested in the physical quality of these collisions. We're only interested in the collision happens. But there are issues. One issue is that no damage is being taken. I wonder why that is. And the second issue is that we're leaving a mess of projectiles all over the scene. So this is where we give you a little challenge to fix this. Here are the things I'd like you to do to get your hands back on the project again. Watching me gob off about it is not going to teach you anything, ultimately. Find the code. 3 things I want you to do. Find the code that's causing that enemy to crouch. Occasionally, the enemy crouches, or yours may not. But if you were to move the spawning point of this projectile down a tiny bit, above, closer to the enemy's head, he would reliably crouch every time he fires off a projectile. Why is that? And where's the code that's causing it? So once you find that code, comment out 1 line to prevent the crouching. As a hint, it's code from the standard assets pack. Then fix the damage dealing code. Damage is not being dealt. Why not? Well, there's a hint at the end of this slide. Destroy the projectiles when they impact the player once you fix the damage healing code. And the hint, if you need it, if you don't want it, pause the video now and just get on with this. If you want more of a challenge, if you want the hint, remember that you need to use on collision enter callback now because the projectiles are no longer triggers, they're collisions. Okay, so we're going to need to change the callback to on collision enter inside the projectile code. So go ahead, pause the video. Let's see if we can mop up all these issues now. Okay, welcome back. So just as a recap as to what we've done in the video so far, we have talked about options for stopping projectiles passing through. We have talked about using continuous dynamic collision detection, not that I updated the thing along the bottom of the screen, but we've done it. And now what we're going to do is we're going to fix the character's crouching on impact issue. So what's happening there with that? Well, let's just open any script and then we can do a find inside our project. So the project is all of the files inside this current project. If we look for the word crouch, do we find anything? I don't see anything yet. Now I'm just guessing at the word crouch, but let's, before we give up on the word crouch, look for the entire solution rather than just the current file. Ah, there you go. In the third person character CS, there is some stuff talking about crouching. What else have we got? When you ask him to move, these booleans about jumping and crouching, we saw them in the first section. But down here, under the move method itself, we've got prevent standing in low headroom. I think that's the one. It looks like the enemy is crouching. He was crouching just then. Let's see, with the code is recompiled. And what we should find is that after the recompilation, he never crouches without that prevent standing in low headroom line running. And that's because that's what he's doing. He's detecting something physical above his head and saying, well, there's not room to stand here, so I'll crouch. In fact, I don't want crouching, or Rick and I don't want crouching the entire game. So I'm going to delete these two lines, scale capsule for crouching and prevent standing in low headroom. And furthermore, after deleting them, I'm actually going to delete the definition of those two methods as well, these guys here. Just delete the whole lot. Loads of lines of code gone. That's a simplification. Always a good thing. All right, so that's the first part of the challenge done. He does not crouch. Comment the line, we've done that. Fix damage healing code. All right, why is no damage being inflicted? Simply because we've changed the projectile to a actual rigid body, to a non-trigger collider, which makes it a physical collider, which gives us a collision, not a trigger. So it's on collision. Now, don't finish typing that word. What's wrong with me typing the word? The problem is this is a callback, and if I spell it wrong, it won't work. So we need to just search for it. On collision, enter. Because the IDE doesn't give us any help, we need to copy this from somewhere. Anywhere will do, anywhere reliable will do, but don't type callbacks. All right. Void on collision, enter collision, and then give it a name. Give the parameter a name. Here you go. And then instead of collider, it's collision. Otherwise, the API is the same. Now, let's see if damage gets done now. The balls will still bounce off the player, but damage should be being dealt. Let's see what happens. Boom. Here we go. And even at a projectile speed of 500, we're getting damage. Awesome. Our projectiles are getting much more reliable. We can see them. They're bouncing. The final bit of the challenge was that we need to destroy projectiles on impact. Now, that's actually pretty simple. After we decide whether we're doing damage or not, we then simply destroy the game object in question. We don't need to delay. We can just destroy straight away because we've already dealt the damage. Let's see what happens. Here we go, we're taking damage. We can't see the projectile now, and that's actually because there's no time for the line trace to happen. So I'm saying we don't need to wait. We actually do, because we need to see that line trace. So there is actually a delay you can put in here. We could try 0.1 of a second delay. That's one of the other signatures of destroy. Let's see if that's enough for the line trace to get drawn. And it is. But it's too much time because the projectile is also bouncing off before it gets destroyed. So let's think about it. Let's think about the fact that this projectile, well, one thing we can do is just search, put another 0 on the end. We could go through a load of calculations, but for the moment, we're not optimizing this. We're just saying, let's try and get a value that's reasonable. And this projectile is so fast that it's not looking great, but realistically, we're not going to be at 500 on this. We're going to be down at 100 or something. And at those speeds, it looks reasonable. It needs to get better than this, but we'll wait till we start customizing the appearance of the projectile before we do that. So before I go, I want to make sure that these changes have been applied to all of the projectiles. The main thing is that they all use continuous dynamic collision detection. They do. That's cool. The player has continuous collision detection on him. I'm going to apply that back to the prefab. Make sure you've done that with your player prefab so it works in other scenes. Talking about other scenes, let's pop over to Rick's Village quickly and make sure that all of this works in Rick's Village. So if I run around in his village and they're shooting at me, am I taking damage? Yes. And can I see the projectiles being shot at me, even if they're fast? Yes, I can. Great. So more reliable detection and more visible projectiles. All good progress. That's enough from me for this video, and I'll see you in the next one.